Last time we started talking about ratios and proportions. We just spent the time just either being introduced to them, or maybe we have forgotten how to do some. We just did a bunch of practice problems. Now we got to figure out how to use those in a geometry class. So we're going to identify similar polygons, and we're going to apply proportions of similar polygons to solve problems. Some vocab. Again, you have to know by now that vocab in geometry is very important. You have to know what these words mean. Similar. This is the symbol for similar. It's a little squiggly line. If it's similar, then we have figures that have the same shape, but not necessarily the same size. They could have the same size, but they don't have to. But they do have to have the same exact shape. Similar polygons. What does it mean for polygons to be similar? Two polygons whose corresponding angles are congruent. So the angles all have to match up and they all have to be congruent. And the corresponding sides are proportional. So again, that's important. The angles have to be congruent. The sides are going to be proportional if they're similar polygons. Similarity ratio is just the ratio of the lengths of the corresponding sides of the similar polygons. And I do have some examples. So just be sure you're familiar with these words. Alright, similar polygons. How far can I go? Let's go here. So here's my shape. It gives me, let me cover it. Triangle, it tells me the triangle ABC is similar to triangle DEF. Again, this right here is called my similarity statement. So now we're just going to match up. My corresponding angles are congruent. How do I know that? Because it tells me. One arc. So angle A congruent to angle D. Two arcs. Angle B congruent to angle E. Again, three arc. Angle C congruent to angle F. So I know all my angles are congruent. That's not enough to show that it is similar. Now I have to look at my sides. So corresponding sides are proportional. So AB to DE. And again, we have to go on this order because if I'm going to go AB, I'm going one arc to two arcs. So if I'm going to go AB this triangle, it must be proportional to DE of this triangle. So AB to DE must be the same as BC is to EF. So AB over DE must be equal to the length of BC over EF, which must be equal to the length of AC, my third side, AC over DF. If I do that, it looks like it's going to be 2 over 1. AB is 6, DE is 3, BC is 9, EF is 4.5, AC is 10, and I do have it written down below, just so you can see better. So AB 6, DE 3, BC 9, EF 4.5, AC DF 10 over 5. Notice they are all equal to 2. So if all my angles are congruent and all my sides are proportional, my shapes are similar. That's all we're trying to show. Alright, example. This was just having us identify the pairs. So identify the pairs of congruent angles and corresponding sides. So I'm just going to match up again. Angle A and angle Q each have 2 arcs, so angle A is congruent to angle Q. Angle B and angle R are both right angles. Angle Q and angle S are both right angles, and angle D and angle T each have 1 arc, so they must be congruent. Just match up your pieces, doing the same thing, the same way we did it up here. Go in order. AD must be proportional to QT. AB must be proportional to QR. BC must be proportional to RS, and CD must be proportional to ST. Yeah, that's all it asks us to do, is just identify the pairs of congruent angles and corresponding sides. Now this one actually wants us to show something. It actually wants us to show whether these two triangles are similar or not. So, what do we know by just looking at the picture? We know angle G and angle K are congruent because they each have 1 arc. We know angle J is 101 and angle F is 101, so we know angle J is congruent to angle F. This little dot's just this fancy way of saying therefore. So if these two angles match and these two angles match, we should know by the third angles theorem that angle E and angle H must also be congruent. So if angle G is congruent to angle K and angle J is congruent to angle F, therefore angle E is congruent to angle H. So I know all my angles match. Now let's check out my sides. So I have 10 over 15. I take this side and I put it over this side. And again, you have to match up your pieces. It is important which side you put over which side. I have 12 over 18, 12 over 18, and I have 17 over 25.5. And if I simplify those all in my calculator, they are all equal to 2 over 3. So my answer, yes, they are similar triangles because all the angles are congruent and the sides are proportional. Okay, let's do another example. Make sure I get this to show. Tells me rectangle DEFG is similar to rectangle HJKL. What is the length of HJKL? This is an easy way to do it. Set up a proportion and just keep yourself organized. There's different ways to set up your proportion. If you don't like doing it this way, you don't have to. This is an easy way to keep yourself organized. So we take the length of DEFG and we put it over the length of HJKL equals the width of DEFG over the width of HJKL. This is an easy way to keep yourself organized. So now we're just going to plug in. So the length of DEFG is 40. That's what's going on top. The length of HJKL, well, that's what we're trying to find. We don't know what that is. We're going to call that X. Equals the width of DEFG, which is 27, over the width of HJKL, which is 18. Now we can just cross multiply, and we should get X is equal to 26 2/3. Again, that's just one way to set it up. There's more than one way to set that up. Triangle MNP is similar to triangle QRS, and the ratio of triangle MNP to triangle QRS is 5 to 2. So now it's asking us if MN is 42, what is QR? Again, this order matters. So MNP to QRS is 5 to 2. So this 5 goes with the MNP, the 2 goes with the QRS. Just keep it the same order. So if I write my my proportion, I have 5 to 2, which is MNP over QRS equals, it's still going to be triangle MNP over QRS. Well, it tells me side MN is 42, so that belongs with the MNP triangle, so that's going to go on top. And the bottom, we're trying to find the length of the QRS side of the triangle. That's what we're trying to figure out. So again, MNPs are both on top. This is the ratio of MNP, this is the length of MN, 5 and 42. This is the ratio of QRS, this is the length of QRS I'm trying to find. And now I can just cross multiply and you'll get X is equal to 16.8. This the bottom part, just the way to keep yourself organized. It's called a Frater model, just a nice way to keep yourself organized. Similar polygons. Definition, again, we already talked about it. Two polygons are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. What does a similarity statement look like? It just looks like this. I could say triangle ABC similar to triangle DEF. Example of similar polygons, like that. And non-examples of similar polygons, like that. There's several different examples you have to choose from. Be ready for a short little quiz.